Okay, guys, we are going to discuss what a secant line is and how it can be used to determine some angle measures today. So a secant line is a line, array, or a segment that intersects the circle in exactly 2 points. So for example, line AB. Then that creates a couple theorems for us, or one theorem that has a couple different parts. If I have two secant lines that intersect inside the circle, I have this formula. Now, it's not that that's a bad formula, but I like to write something else so it's a little bit catchier. Since we meet inside, notice how the angles we're discussing are both outside. So I think I like out plus out divided by 2, meaning this is my first outside arc, this is my second outside arc. You add them together and you divide by 2. It still looks like out, T out. Let's do this. Out plus out divided by 2. We'll do all words. Okay, next we have examples of where they intersect outside of a circle. It's half the sum of the measures of the intercepted arcs. So this one, would you agree with me that this arc here is, say, bigger than this arc? And same thing here, this arc is bigger than this arc, and this arc is bigger than this arc. So I'm going to use the words big arc minus small arc divided by 2. Don't worry, we'll get to the theorem book in a moment. So we're going to go ahead and find the following pieces of information. So these guys, they meet in the middle. So I'm going to take outside plus outside divided by 2, which is 136, which gives me 68 degrees. Oof, that's a rough 8. Next one I have letter B. We can see the photo. There it is. We meet outside. So I'm going to take the bigger arc minus the smaller arc divided by 2. So that's 95 minus Z divided by 2 equals 20. So 95 minus Z equals 40. So Z is equal to 55. Again, for C, we meet outside, so I take my bigger arc, which is W, minus the smaller arc, which is 110, divided by 2 is equal to 70. So I get W is equal to 110. I'm sorry, too many silly things. W minus 110 is equal to 140, so W is equal to 250. Again, we're meeting outside. So we're going to go ahead and have my big piece, which is 110, minus my small piece, which is 30 divided by 2, which gives me 80 divided by 2, which gives me 40 degrees. Okay, another outside one. So 268 minus 92 divided by 2, which is 176 divided by 2, which is 88. And then I have another inside now. This is the angle I'm looking for. So it's x plus 112 divided by 2 is 94. So I have x plus 112 equals 188. So x is equal to 76 degrees. Okay, we have a second theorem. We can find the segment lengths based on the following formulas. And again, I think these are a little kind of hard to read, so I came up with my own general idea. And after a while, it's going to look like they're going to flow together. So I'm going to make sure we have them separated. This first one, I have when they meet inside, we have kind of pieces of the line. So this piece of A gets multiplied with a piece of B, and then this piece of C gets multiplied with this piece of D. And notice how I'm saying pieces because it's not an entire length, it's part of it. So I came up with the new saying, again, I came up with this, doesn't mean you think it works. I think it's easier to remember than A times B equals B times C, or C times E, because what do those even mean? What does that even mean? So piece times piece, or I'm going to do it this way. So piece times piece equals piece times piece, and that's kind of tiny. So I take the piece of one line times the piece of the other piece of the same line, and then they should be equal to each other. If you meet outside with two secants, I have, again, that's a little too large. We do outside times the whole is equal to outside times the whole. I'm gonna do that. So if you look at this one, W plus X is the whole distance, and then you have just W, which is just the outside guy. And then the same idea, you have Z plus Y, and then you have just Y. Oof, those are really bad color choices. Okay. Again, just general things, different wording. I think it's just easier to see. That's just me. And then this time when I have a tangent, I have outside times whole equals tangent. This is large. A little bit bigger than I wanted. Squared. I'm just going to say tangent times tangent. I wanted tangent squared, but so again, what does that look like visually? So the outside, or the whole, times the outside little piece, and then is equal to the tangent of the guy squared. So again, I think the words are easier. I can visualize it a little bit better with the different words that way, but it's your choice, whatever you want to work on. I will continue to refer to them as outside and whole and outside and whole and piece and piece. So we have two secants here, so this is an outside times a whole times an outside times a whole. So my outside piece is 6 times the whole thing, which is 6 plus 8. And I want to write that out so I don't forget, because later on it might not be a number, which is equal to the outside piece times outside piece plus the whole, which is 6 times 14, which is 84. And then I get 49 plus 7y. Subtract over 49 and I get 35. Oops, going into my face. Which is equal to 7x divided by 7. X is equal to 5. Or y, I'm sorry. I wrote so sloppy I couldn't tell that I had a y. Oops. So used to it just being an x. All right, on B, I have a tangent because it's only got this little section here. So I have the outside times the whole is equal to the tangent squared. 16 plus 8 is 24. 8 times 24 is 192. To undo a square, I square root. So z is equal to 13.9. Letter C is similar to letter A. So they are outside, which is the 14 times the whole, which equals outside times the whole. Oh, 14 plus 20 gives me 34. 34 times 14 is 476. 16 times 16 is 256. Subtract over 256 and I get 220. Divide both sides by 16 and I get x is 13.8. I see I have my first pieces. So this is one line. Can't really see that. This is, oof, nope. Just not getting what I want today. This is one line. This is the other line. So I have 6.5 times m is equal to 3 times 7. So then I get 6.5 m equals 21. Divide both sides by 6.5 and I get 3.2. 0.2, not 32. I have another piece problem. This is one piece. This is the second piece. So I have 5 times x is equal to, oh, wow, you probably won't be able to see this yellow. 3 times 7, oof, that's rough. Yeah, it's a little rough. I'll change it to a gold color. Maybe, if it will respond. So I have 5x equals 21. So x is equal to 4.2. And this last guy, I have another tangent. So I have the outside. I'm going to switch from black because I just wrote the last two in black. So the outside times that whole, which is equal to the tangent squared. So I have 8y plus 64 equals 225. So I have 8y is equal to 161. So y is equal to 20.1. All right, let's go ahead and discuss our formula book entries. Now again, I discussed some of these in terms of words. So what you're going to see in terms of the wordage I use. If you didn't like those, then keep them what you have. I have two different sections for secant lines. So this is the first one where they meet inside the circle. And there's my examples. Yes, you can see I had a mistake and I couldn't draw very well. And then my second secant line is where they meet outside. So says big and small. And I had to pick 2 examples. Then I also have one for the segment lengths. Again, using that terminology we discussed. And I have one of each type.